Alright, in this video we're doing a reassessment for circular motion, and our first step is to draw the free body diagram for the cart at the bottom of the roller coaster and at the top. At the bottom we have the normal force going upwards perpendicular to the track, and we have the mass and the gravity going downwards. And for at the top of the track, we have the normal force going down perpendicular to the track, and the mass and the gravity going down. Alright, the next step, we're going to list our givens from the problem. And the mass was 755 kilograms. The acceleration at the top of the roller coaster was 12.3 meters per second in a downward direction, and at the bottom it was 19.4 meters per second squared in an upward direction. Alright, and the problem wanted us to find the normal force at the top and the bottom. Okay, so we get our equation for at the bottom of the loop. F net equals mass times acceleration. And since it's in the y directions, it's F net y equals 755 kilograms times 19.4 meters per second squared. And here's our free body diagram. We have the downward force of 7,399 newtons, and that's just the mass times gravity. And then what we're trying to find is the normal force. So the equation will come out to the normal force equals the force of gravity minus the net force. Yeah. And that comes out to 14,647 plus... Wait, did I do that backwards? Yeah, it did. That's supposed to be a plus sign. Okay. 14,647 plus 7,399 gives you 22,046 newtons. And then we move to step 4 and set it up for the top of the loop. And I just took the cart out for this one so it'd be a little bit easier. We have both forces going in the downward direction. So we have F net equals mass times acceleration, which was 755 times 12.3, and F net equals 9,286. And for this one, the normal force and the force of gravity have to combine to supply the required inwards net force of 9,286.5 newtons. So you get the net force minus gravity equals 9,286.5 minus 7,399, and the normal force for the top of the track is 1,887.5. So the answers to the problem is BOT equals 22,046 for the normal force in the upwards direction, and for force top is 1,887.5 newtons downwards.